Welcome to Ms. Taylor's class notes, and today we're going to be talking about linear equations and all of their key features of them, as well as how to find slope from a graph. So we're going to spend the next 3 to 4 months talking about linear equations. Linear equations are straight lines. They do not bend. They go straight up and down in one direction. And it can be many directions, but they are going to be perfectly straight. The biggest thing we always end up talking about with linear lines is we talk about slope and rate of change. And before we get started on defining these things, I want you to know that slope and rate of change are the same thing. They are two different names, but they mean the exact same. And the way that the STAR test and even the tests that we're going to give this year, they're going to use slope and rate of change in different questions. But they always mean the same thing. So slope, we use the letter M to represent slope. Slope is the rise over run of the line. Rise simply means the change in the y value, which is the up and down of the line. Run means the change in x, or the left and right change of the line. And again, rate of change is just slope, which is the letter M, which equals rise over run, which again is the change in y over the change in x. Our y-intercept is probably the next most important thing that we talk about when we talk about linear equations, because our y-intercept is important to help us graph lines. So we use the letter B to represent the y-intercept, and the y-intercept is where the line crosses the y-axis. And so the last two things we're going to talk about are x-intercepts and zeros. And x-intercepts and zeros, just like slope and rate of change, are the same thing. These aren't something we talk a whole lot about with linear lines, but these are terms that we'll use when we get to quadratics later on in the year. But you'll occasionally see people talk about x-intercepts or zeros with linear lines. So an x-intercept is where the line crosses, oh no, I can't spell today, crosses the x-axis, and our zeros are simply x-intercepts. And we're going to talk a lot more later about why that name zeros exists, but for right now it really doesn't apply to linear. So let's look at this graph and let's try to find some of these key terms or phrases. So when we look at slope, we want to find where the graph or the line hits a corner of the graph. So that was a good spot there. We're going to keep checking the corners. Not a corner, not a corner, not a corner, not a corner, and now we have a corner. So the change in y from dot to dot is 1. The change in x is 1, 2, 3, 4, 5. So our m, or our slope, is a negative 1/5. And we're going to talk later about why it's negative. But that's not right now. I just want to kind of talk about slope. So the next thing that we talked about was our b. I don't know what just happened. Sorry, guys. I was trying to get the right color. Our b is our y-intercept, or where our graph crosses the y-axis. So we're looking here. And I'm going to guesstimate that that b is about 7.5. And the next thing we talked about was our zeros. This one, on this view, we have no x-intercept. Eventually, that line is going to cross the x-axis, but we cannot see it here on this graph. So I want you to use what we just talked about, and I want you to find the slope, the rate of change, the y-intercept, the x-intercept, and the zeros for this graph here. Use the graph above and our definitions to find them. And then I want you to check your completed answers with the class notes, or with the completed class notes. All right, so now today we're going to spend the rest of the day talking about slope. So when our slope is going uphill. Now, one thing I always want us to know is we read a graph from left to right. Everything we do on a graph is from left to right. So as we go left to the right, if that graph is going uphill, then we have a positive slope. which means that as we go from left to right, if our slope is going downhill, it's going to be a negative slope. And that's how I was able to tell in that last one, is because it was going downhill, I knew my slope was going to be negative. The next that I like to talk about is this is a flat line. So if you've ever watched a medical drama or just a show where somebody gets sick and they go to the hospital, they come up to the heart monitor and their heart stops, they call it flatlining because in the heart monitor they have 0 beats and it creates a flat line. And so a flat line means that our slope is 0 because our line doesn't have any heartbeats. And then finally, this one's, I don't have a good answer for this one or a good way to remember it. It's just undefined. Straight up and down means undefined. So when we use a graph to find slope, we use rise over run, which is the same thing as our change in y over our change in x. So let's look at some examples. So here, our graph is uphill, and so because it's uphill, we know it's going to be positive. And so we're going to count the change in y, so the up and down, it goes up 1, 2, 3, 4. Now, this graph was really, really nice. They gave us dots already, which makes it super duper easy. We just count from the dots. And we need to count the change in x, which is left and right, 1, 2, 3, 4, 5. And so our m equals 4/5. When we write our slope is always going to be in fractions or whole numbers. We will never use decimals to represent slope. It's always going to be a fraction, and we always need to reduce our fraction if at all possible. And there are ways that our calculators can help us with that if we're not very good at it ourselves. So now let's look at this next line. This next line I know is downhill. And so because it's downhill, I know that my slope is going to be negative. So I can go ahead and write m equals and put my negative there. So the change in y, which is my up and down, is 1, 2, 3. And then my change in x on my left and right is 1, 2, 3, 4, 5, 6. So my slope is not a negative 3 over 3, is a negative 3/6, which I know I can reduce that to a negative 1/2. And so that is our slope there. And one way I can kind of show that is if we had drawn our own dots, I would have drawn those dots right there. And so our change in y would have been 1, and our change in x would have been 2. So it doesn't matter which 2 dots you use in a line, as long as you're reducing your fractions, you're always going to get the correct answer. So if you're paying attention up top, we know that this is going to be undefined, but I want to show you why it's undefined. So we always write our slope as our change in y. So let's calculate our change in y. 1, 2, 3, 4, 5, 6. So it changes 6 up and down. But if we notice, it does not move left and right. And so if it does not move left and right, our change in x is going to be 0. And so because we have a 0 at the bottom of our fraction, that is what tells us that it is undefined. Whenever that run or that change in x is 0, that's what makes a line undefined. And same thing here. We know this is a flat line. So we know that our slope is going to be 0, but I kind of, again, want to talk us through why. So the change in y, or the up and down, is 0. Our change in x, or our run, is 3. And so because we have a 0 at the top of our fraction, that is what tells us our slope is going to be 0. We can have a 0 at the top of the fraction, which is why it becomes 0, but we cannot have that 0 in the bottom. So I want you to do these 2 graphs on your own, and I want you to check them with the completed class notes.